guys, today we are going to talk about cardiomyopathies, right? So we shall start by the definition and classify them and talk about one of them, and we'll see how we can progress from there. So cardiomyopathies, so by definition, cardiomyopathies are intrinsic myocardial dysfunction. Go together, intrinsic myocardial dysfunction. So what does this mean? It means like if you have a problem with the muscles of the heart, so that's why we call it cardiomyopathies. So the cardiomyopathies, we can describe them into three. One, we have the primary, secondary, and idiopathic. Now, primary cardiomyopathies, these are cardiomyopathies that by principle or principally confine to the myocytes or the cardiac myocytes. So they are by principle, they are confined to the cardiac myocytes. And secondary, these are manifestations of systemic disorders. And idiopathic, these are cardiomyopathies whose cause is not known. Now, there is a lot of question about this because some diseases were formerly idiopathic, but because of improving technology, they actually got to know their cause, and most of them turned out to actually be genetical. But we shall see it in detail as we progress. Now, the cardiomyopathies, according to the pathogenic patterns and clinical manifestation, because of a lot of diversity of these diseases, it was really hard to classify them. But finally, they came up with a system of how to classify them into three also. So we have three. So according to the pathogenic patterns, we can classify them as dilutive cardiomyopathies, hypertrophic cardiomyopathies, and restrictive cardiomyopathies. Now, we shall talk about all these three individually and in detail. But let's first start with the dilutive cardiomyopathies. Now, you will notice that in most of our videos, when we are talking about the pathology, we talk about the pathogenesis, morphology, and the complications. Now, first, I will talk about what is the dilutive cardiomyopathies. Now, with dilutive cardiomyopathies, actually, the chambers of the heart are enlarged as a result of different reasons. Okay, so here we have progressive dilation of the heart chambers. Right? And also we have cytosolic dysfunction or dysfunction. Now, what does it lead to? It means we have a problem with the contractility of the heart. Are we together? So, how does it happen? What are the causes? Now, the causes can be broadly classified into genetic causes and non-genetic causes. Now, the genetic causes contribute up to 20 to 50% of the causes. So most of the DCMs are actually genetic, and the non-pathological or the non-genetic causes, we can say we have a couple of them, but I'll talk about the most important or the most common one is pregnancy. It's important to know a lot of changes as caused by pregnancy, and one of them is what we call the pregnancy cardiomyopathy. We have also tachycardia. We have also stress provoked. We have toxins, and we have many more. We have myocarditis, which is inflammation of the cardiac muscles, but we shall see it in our later video about rheumatic fever and stuff like that. Okay, so genetic causes, we also have a few. I will mention them briefly. First, usually the genetic cause of DM are those ones that really affect the contraction of the heart. And first of all, a genetic mutation in proteins that code for the cytoskeleton, in proteins that code for proteins that connect the cytoskeleton to the sarcomere, but most frequent is the X-linked causes, and the most implicated protein is the dystrophin. So actually, this is an important protein in the contraction of muscle. If you have a mutation in the contraction of muscle, definitely the contractile capabilities are going to be low. And what if the heart cannot contract easily, it means a lot of blood is going to stay in the heart. Therefore, the chambers of the heart will become enlarged as a result of volume overload. That's one. The cytoskeleton proteins are also important because they are important to the structure of the cellular structure of the cardiac myocytes, and more details altogether. So that being said, I also talk about a little detail about pregnancy. With pregnancy, one, during pregnancy, I will try to squeeze it here. So during pregnancy, we have, mostly at the later form of pregnancy, we have high prolactin levels. Now, what does prolactin do? Prolactin is going to inhibit angiogenesis. What is angiogenesis? Angiogenesis is the formation of blood vessels, right? Now, how does it manage to do it? So, because of high concentration of prolactin and angiogenesis inhibition, it does so by inhibiting the VEGF. Now, this is a hormone factor that is responsible for angiogenesis. Is that clear? Now, the toxins. Now, alcohol, for example, is a toxin, and alcohol, the product of metabolism of alcohol, one of them is acetaldehyde, and it is toxic to heart. And also, in chronic alcoholism, we have impairment of thiamine absorption, and therefore will lead to a very heart, okay, which we will probably talk about in our future different topics. Anyway, so that is that about it. Now, let's focus our attention on the morphology of DCM. So with DCM, first of all, we have problem with contractile heart. We have the problem with the structure of the heart muscles. So one of them is that, first of all, they are thin and flabby. Now, because of this thin and flabby, there is always a high tendency of rupture. Two, there is a high possibility of formation of a neurothrombosis. 3, there is also concurrently, you can have hypertrophy. Is that okay? Now, what does this morphology of the heart? So, morphology of the heart in this condition literally means how does the heart look when you are attacked by this or when you have this condition. So, it's generally a big heart and not in a good way of big, and with all the chambers of the heart are dilated. Okay. So, that's basically it with the morphology. We'll talk about the complications. Now, as a result of transmural thrombosis, definitely you can expect embolism depending on the ventricle of the heart that formed the thrombosis. You can end up with different complication or infarction in different places. 2, a lot of blood is staying in the heart. Definitely, it will lead to hypertrophy. That is another complication, but I had already mentioned it in the morphology. Hypertrophy. And consequently, it will lead to heart failure. Are we together? So, with that, we will conclude with the dilutive cardiomyopathy. Please check out our video and our future videos, and like our page and subscribe. Other thing is like we shall talk about next is the hypertrophic cardiomyopathies in our next video. Thank you.